everyone. Thank you so much for coming. My name is Maeve. I'm one of your Honors Presents directors for this semester, and we're super excited to have you this afternoon and to have Professor Everts with us. So, first off, if you are interested in hearing more about Honors Presents or being involved with it, please come talk to me afterwards. I will also scan you guys for your text and critics credit if you need it afterwards. And Professor Everts will be around to answer questions a little bit afterwards as well. So, I will begin with our land acknowledgement. We begin by acknowledging, with honor and respect, the indigenous nations on whose traditional territories the university now stands, and whose historical relationships with the land continue to this day. We also acknowledge the elders, past and present, including MSU's current Council of the Elders, and humbly ask for their guidance. The Valley of the Flowers has been and remains a place of learning for Native American peoples, who for millennia have passed ways of knowing, being, and doing from one generation to the next. While land acknowledgement is not enough, it is an important social justice and decolonial practice that promotes indigenous visibility and a reminder that we are unsettled indigenous land. Please note that the Honors Presents lecture series welcomes diverse opinions, beliefs, perspectives, and experiences, and our presentations are that we host are a reflection of an individual's unique expertise. And I will let Professor Everts take over.
Okay, thanks, Maeve. I appreciate the invitation. So, Mike Everts, I'm an architect, and I've been at MSU about 19 years, and before that practiced architecture in Chicago. And so today I'm going to talk about what design means, expanding the definition of design to include other disciplines besides what you might normally think of as designers. And I'm going to go through 10 projects that illustrate different principles of that. What are some of the different majors? I'm curious. I know there's architecture here, a couple. What are some of the other majors that are here?
Pre-med.
Pre-med?
Psychology.
Psychology?
Sociology.
Okay.
Mechanical engineering.
Mechanical engineering. Okay. Computer science. Great. Okay. Wide spectrum. So this is a picture of Herbert Simon, and he won the Nobel Prize in Economic Sciences in 1978. And he had a theory of economics that economic profit wasn't motivated by one thing, which was maximizing that profit. He theorized that actually it was a combination of considering comprehension of what you could understand, what people could understand, the time you had to do a design problem, and the complexity of what that problem is. And that as a designer, you navigated between those three things to find a solution. And he thought of his theories as a basis for actually a design curriculum. That wasn't just for what you normally think of designers. As a matter of fact, he thought of his theories as a way to bridge disconnected communities and to have more meaningful collaborations. Similar to that, but more recently, this is Bruce Mao, and Bruce is a graphic designer, Canadian graphic designer. And a while ago, he wrote a book, he has a website, he tours with this, he's had shows with it, this idea of massive change. And part of his idea is, and you can see he thinks big. This is the mission statement for Massive Change Network. He thinks big, he's optimistic, and he thinks about collaborating. And so I'm going to read a quote from him of how he thinks of design, which kind of epitomizes what I'm going to go through here. We should concentrate on the idea of what design makes possible, its capacity. We think of design as visible, but so much of it is invisible. Massive Change Network is about taking aesthetics off the table and focusing on the capacity of design. So normally when you think of design, you think of it as a noun, right? The design of this chair. You don't think of it as a process or as a verb of something that's continually done. And so that's part of what I'm advocating with design everything, is not that you just design more objects, but you think of design as more of an extended process that reaches in different directions. And so I'm going to talk about different ways that you can approach design that would advocate for that. One is your attitude of design, the vocabulary, and expanding that from not just the words you use about design, but non-verbal communication, vocabulary. Tools for thought, and then meta-design, thinking about designing more things. So the first one is attitude. And one of the attitudes of design is you could design like, okay, I just have to solve this problem. But adding on to that of improving on what came before and making the world a better place, of extending it. And so the example I'm going to give is a project that the School of Architecture did in Fort Peck, Nepal. This is about 2 days south of Mount Everest. It's a small mountain community, about 360 people, mostly Sherpa, and it's right on the route to base camp. And so many of the Sherpa who live here actually work as porters, guiding people up to climb Everest. And Conrad Anker and Jenny Lowe Anker, who live here in town, have started the Kumbu Climbing School. And before they had a building, they taught the school, and their mission was to teach Sherpa more technical climbing skills, English, medical skills, so that they wouldn't have to be porters, that they could also be guides and actually earn a living. And it would be less dangerous for them. So they started that in 1999. Then they came to the school and they said, we'd like a building to house this climbing school in Fort Peck. And this is a closer up of what those typical structures look like. And so these houses, and many of them are 500 years old, and the typical construction is dry stacked stone. So the stone is from the area, they have plenty of it, and they stack it up, there's no mortar there. And typically what it was on the lower level you had livestock in there, and then you'd live above that, right? The heat from the livestock would rise up. But when we came, we did a few other things with this building, but I wanted to talk about 4 things that we took on this project, and this was in keeping with the challenge that Jenny and Conrad had given us, was to make things better. And some of the things that we decided to make better were the design process of doing the climbing school, addressing earthquakes. They're on the most active fault line in the entire world. Heat. They heat for their structures, they burn yak dung. They're in a natural forest, so they actually can't cut down wood there, so they burn yak dung. Yak dung, the fumes that come off of it, cause birth defects, all kinds of health problems. You can imagine that's at 12,500 feet about, so it's pretty cold up there. And then the last thing, the 4th thing, was new uses for the building. So these are the students that we started the project with, and we went to Fort Peck, and we went there with the intent of doing some community design charrettes on what the building could be. And these models right here, the students had done all this research ahead of time, had done research on the historical structures, on what they were, right, what the roof pitches were, the material, all this other kind of stuff. And so after the first day, they did these models, and they were kind of like these green roof models. And the next day, these community members came in, about 30 members, and they were looking at the models, and they didn't look particularly thrilled with what we had done. And so we asked Chongbada Sherpa, who was a guide since none of us spoke Nepalese, like, what was up, what were they thinking? And they're like, well, first of all, they really appreciate you being here. But their main question is, or comment is, that what you've done looks a lot like what we already have. Why would we need you to do what we already do? Like, what new thing are you bringing to the table? Like, why are you here? And it was interesting because it was such a relief for the students, right? Like it released all this creativity, the things that I had thought about. Like, it's not about not respecting culture or anything, right? It's just about bringing creativity back. And so these other models, like there was some pretty crazy stuff in here, but they kind of started to push the border on like what could be done. So that's with the design process, that there's a value to not always repeating what's there or having people that are local just do the stuff, of having other opinions into the process. The second thing that we did was address earthquakes. And so with earthquakes, earthquake is a lateral force, right? It comes from the side, it doesn't come up and down. And so with these being dry stacked stone, what happens is the stone shifts to the side and the roof collapses, and you can imagine, right? It kills people. These are images from and you probably heard about it, the 2015 earthquake in Nepal. These are images from that time. The building was actually under construction already at that time. And so what we did was we still did dry stack stone. This is actually a close-up. The grand opening for the building was 2 years ago. It took 14 years to do for a number of different reasons. But we took the dry stack stone, we used that same construction, but then we integrated, like when you hike up there, these long cable bridges, right? And so they had the aptitude of using cables, but they didn't use them in their buildings. So what we did, and we worked with a structural engineer in town, Ty Monks, and these cables, you can see right here, they run the top of the building. There's a metal frame that goes around the stone there, up here and at the bottom. We use those cables to compress the stone, and when you compress the stone, it gives it lateral stability. And so it was a very similar type of construction, except mixing technologies that they weren't using in the building into the building. The other thing was heat. Most of the buildings that I showed on the terraced land, they have the land terraced because they grow potatoes up there. It's an agricultural community for the most part. And so the buildings were oriented according to the terracing. The optimum orientation for a building for solar gain was just at this altitude and this location anyway. It was just a tad east of south. And so we modeled the building, and these are radiation studies. Especially at 12,500 feet, the air is incredibly thin and there's a lot of sun in the winter. And so we were able to orient and create the volume of the building to maximize heat gain so that we could have the building entirely passively heated, that we wouldn't have to burn yak dung in there at all. This is an image of the grand opening a couple of years ago, and so you can see the windows that are in here. Here's another thing that we put in there. All of the windows in the buildings are single pane, and they didn't use insulating glass, 1 inch thick, right? Thick double pane with airspace in it. And so this is the first building up there that did that. It was kind of a funny story, not trying to a little bit tragic, but we were in Kathmandu trying to source it, and there was one supplier said, "Oh yeah, I can do insulating glass." Not a problem, we'll manufacture it. So he had manufactured a bunch for this. And when they were portering it up, I think it was probably about 8,000, 9,000 feet, the windows started popping and breaking. That airspace, if you look at insulated windows, they usually have a wick out to allow for the pressure change. And so this guy hadn't done that at all. So all the windows started breaking. So we didn't end up paying for those, but if you ever go up here, you can see some of those shops and stuff like that, broken pieces of that still. So we got another supplier put that in there. So not only could we get the heat, but once it was in, we could keep it by having an insulated building, which they hadn't had up there. And then new uses, because there was a climbing school, there's an indoor climbing. This is at the grand opening, they had climbing competitions with at the inside. And so it was a heated space, which they hadn't had so much of, and then climbing on the inside. The next project, or the next point, besides an attitude of making things better, is thinking of your vocabulary for design. And so there's certain words that you use in design, but then there's certain processes that you can use, and that process of how you think about design then influences what the design actually is. And so the example that I'm going to give here is actually a personal project. that I did a while ago, and it's exploring the idea of what if you actually inhabited the space of your vocabulary, of your routine. And so this was a time we were living in Chicago, and in living in the city, you have a certain way and a certain pattern of your routines of how you live in the city. And at that time, this was a bit ago, ATMs, automatic cash machines, at that time there were like 230,000 like that all over the city of Chicago. And so when we got cash, it'd be like, okay, we're going to a movie, we get cash right at the movie, right? And so that getting of cash, of where we got it, how much we got it, when we got it, was a pattern of how I inhabited and our family inhabited the city. And so we mapped that. So I took, this is a printout from the bank, of all of my automatic cash withdrawals for a month here. And it starts to categorize them by frequency, how many times I went to the same machine, its location of where it was, the date, and how much it was. And so started to map each month and did it for 6 months. And so this diagram is an abstract diagram of a mapping of that access to cash in the city. I think this one is December. I think this is Christmas because this is the amount and it actually goes off the charts. So it's a buy tips for people. So then it took these months and overlapped them. So January and February overlapped. And where they overlapped, the line, the orange line that you see is their coincident space, right? So it doubles the probability, or it identifies the probability of when that would happen. And then looking at this, these abstract coincident lines here, started to see two different patterns. One are these kind of long ones, right? And the other one is this kind of highlighted pattern. So this is a narrative of how I lived in the city. One way of kind of mapping how, right? Like if you ask, I don't know what a good example is. Like if you look at somebody who runs, right? Like two people might be running, but the way they run is very specific to who they are. And just the way that you live in a city, although people might go to the same type of places, the pattern of when and how they do starts to be unique to them. And so this, what would it be like to inhabit this space? And so one of the things in architecture, sometimes we start design is looking at precedents, right? Like if you're going to design a gym, right? Well, I'm going to look at all the other gyms before me, see how they did it, use kind of lessons learned on that. Another way to think about it is looking for allies, people that are maybe exploring some of the same concepts that you are and looking at how they have done it. And so it doesn't have to necessarily be a building. So one of the allies that I looked at was, this is scenes from Christopher Nolan's movie Memento. I don't know if you've seen it. But it's the story of this guy who experienced this very traumatic incident and he loses his memory. And so he's trying to investigate what happened, and as he finds clues, since he can't remember the clues that he finds, he tattoos them on his body. And so in the movie, in order for Christopher Nolan to tell the story, this narrative of this person, the majority are these color frames, and it goes forward in time 4 days. Woven in that is a black and white segment that you can see here, and it's about 4 hours, but it goes backwards in time. So you have these two kind of woven together, right? Going forward in time with the color part of it, and then you'll have this scene that's black and white that's actually at the end of the movie coming backwards. And they come together right at this point. So he changes the scale, he changes the direction, right? And kind of weaves these together in order to tell a narrative. And so he uses a similar type of structural approach to this. This is all together. So So it takes the bigger part, which this is the analogy, the color part of the film, and then this would be the black and white film, so I took expanded the scale, turned it around, and moved it together, and this is what that space looked like. And this is the space. Then this is the house in its neighborhood. Not sure it meets the zoning codes, but anyway, joke. The third thing, so we talked about attitude and vocabulary. The third thing is tools of thought. The tools you use to design influence what the design is. Like for example, if you think about Twitter, right? And people aren't saying anything they can say. They're using those words, 140 characters or whatever it is. Like everything is limited to that. So that is partially determinant on what's said, right? You have to be dramatic, you have to do all these other kind of things. So the tool makes a difference. So many times when you do designs, it's helpful to use multiple tools so you can get different perspective. The other thing is to stay liquid as long in the process as possible. What that means is stay flexible. Don't design one part of it and say, okay, that's done, let's move on. Design's not a linear process. Sometimes you might be doing something and you become aware of something later in the process and you want to change it. And then the third thing is constraints on this. You'll hear this many times from architects is, if I didn't have to meet the building codes, I could do this fantastic design. Oh, if the client didn't have this budget and I had more money, everybody could see my genius because I could design this fantastic thing. Those are constraints and those are part of the project. And instead of using them seemingly a limited way of limiting your creativity, use them as ways to actually increase your creativity. This is a project we did a few years ago. This is a climbing boulder over by Yellowstone Hall over here. And the recreation director at the time came to us and they had actually hired Stronghold Fabrication. I apologize, you guys got to hear this in there. Stronghold Fabrication in town. They built the other boulders that are on the Galligator Trail. And so they already had a budget for how much this thing cost. And they said, okay, you can't change that. The budget is the budget. And you can do whatever you want as long as you stay to that budget. So we met with them and we said, okay, well, what determines the budget? And they said, well, it's three things. One is the surface area of the boulder because they spray it with concrete. And so there's a specific cost to that. So you can have any shape as long as that surface area is the same. The other thing, since there's a metal frame on the inside, is the length of steel that you're using. I forget what the exact length was, but you can't go beyond that because of the cost of material. And then the third thing was the number of joints, because every joint is welded and that costs money. So those three things. So we created this script, which is just a Grasshopper Script. And in the script, it baked in those parameters, the surface area, the number of joints, and the length of steel. And so it had these sliders that you could move to change the shape of the boulder, but it always kept within those parameters. So any shape that you came was automatically within budget, because that's what was determining budget. And so we did a community workshop with that script where these different climbers adjusted the shape of the boulder to see what they wanted. And we had Conrad Anker was there, so you had like the pit, right? He works for North Face, the opinion of a climber. And then we also had other people. One of the people, he was actually an architect who graduated from our program, Neil Baggett, was a climber. He was in a wheelchair. And what was interesting was when he was adjusting, he said, because I don't have the use of my legs, I really prefer, when the surface comes back like that, so I can concentrate on my arms and climb up. And I said, well, that makes sense, right? So he's not dragging his legs over the surface. And then other climbers that had like super abilities, like Conrad, right? They also preferred that because it was more challenging. And so it was interesting that the same shape of this fit for both that kind of wide variance of abilities, right? Anyway, That's that project. This next one is a project that the School of Architecture worked with, and it is the Sourdough fire station just south of town, which is built. And before they came to us, they being the Sourdough Fire Board, they had gone out for 2 bonds before that over the course of 10 years, and both of them failed. And one of the reasons that they failed is because they designed the fire station building, and they put the design out that the community members would vote on, I needed $3 million or whatever, to build that. And people, it's like, okay, well, we don't need another building like that. So the tact that we approached it with, and this again has to do with the tools that we use, is to basically just pitch the performance of the building. Not the design of the building, this is not the aesthetics of what the building is, but its capacity to do different things. And so we started out with these diagrams, and one was just south of town, that in 10 years' time, the amount of structures was going to double. It's actually surpassed that. And the other was, they didn't have firefighter volunteers, which are actually mostly MSU students, living in the fire station. And so they would be on call, they'd get the call, they had to drive to the fire station, get their gear on, and then go to adjust the fire, right? And so this black circle is the radius with that they could achieve because of that time difference. And so by having them live there, they could respond quicker, right? And probably, you may not know this, but that first 10 minutes is the most critical. After a fire's been going for 10 minutes, things can reach, I think it's called flashover point, at which things, the time it becomes so hot in there that things spontaneously combust. And so it's like critical to get there in that 10 minutes. And so by having firefighter residents live there, it expanded the area that they could cover and shorten their response time. So these 3 diagrams are with regards to emergency response. And so we just talked about the site. And of course we had to put a schematic design for a building in there, but it was more of a placeholder, because after the bond passed, or it passed, they hired an architect to then design the building according to these performance guidelines. And so we just talked about the site, right? The kind of circulation of getting fire trucks in and out fast. We talked about inside the building and having where they sleep to get out to the fire trucks quick. And then we talked about making a building that was earthquake resistant and high wind tolerant, so that the building could be used as emergency shelter for the community in times of need. And then we looked at it from an environmental standpoint and said, okay, the shape of the building needs to minimize the surface area for the maximum volume, because surface area is where you lose all your heat, right? It's an energy thing. And then we said, okay, it needs to be self-shading, the good sun in the wintertime, natural ventilation, so you get the air conditioning. And then we advocated for a transpired collector, which is basically an airspace on the south side, so that when the building heats it in winter, you're not taking in like negative 20-degree cold air and then heating it up to 65. This actually passively warms the air, so that you're just taking air from like 45 degrees to 65, so you use a lot less energy for that. So these were, and actually the bond overwhelmingly passed. They hired an architect and had it built. Next project is a project we've been working on for a few years on the Fort Peck Indian reservation. The Fort Peck buffalo have been were eliminated about 130 years ago from the eastern plains of Montana. And so the Assiniboine and the Sioux tribes, the buffalo is a foundational part of their culture. And so they've brought back buffalo, and there's like more than this, but 2 basic kinds of buffalo. One are ones that have cattle genes in them, right, that they raise for meat. And the other are the buffalo like you see in Yellowstone. And the buffalo in Yellowstone are the pure DNA, which are the same exact buffalo that used to roam all across eastern Montana. And so they currently have a herd of about, this is about 15,000 acres. And they have a herd of about 500 buffalo that they have right now. It's been growing and they're doing a fantastic job of bringing it back. They wanted their culture to be able to experience the buffalo again. And so our charge was, and actually students came up with this idea. One of the ideas that they came to us with is they wanted to create a pasture for buffalo that was closer to the highway. And like, that's a little, like, not so much, right? Kind of gimmicky. And so students came up with this idea of a path that you'd walk through the buffalo ranch, right? And you'd be able to experience in some way this buffalo. And so this is about 7 miles long, concentrating on the lower south part, which is about 4 miles here. And so one of the things that we thought of with regards to the trail was a way that people could interact with the buffalo. Not directly, right? They're a little dangerous. But in some way that was culturally significant. This is Lois Red Elk, and what she's holding is called the talking stick. That's decorated with culturally significant icons and colors, and elders use it to tell stories, mostly to youngsters, right? That are culturally significant stories. And so we took that idea and said, what if these are like bigger, right? Like 11 feet tall, like what could they possibly be? And so this is a woven willow, and a woven willow or a diamond willow, what it is you take a willow tree, the smaller ones that grow, and they'll grow up and they'll get a disease and they'll grow around that diseased portion, come back, they'll get diseased again, and they go like that. And if you cut a diseased piece of willow, you see these diamond patterns that are caused from that. That's the diamond willow. And that is what they usually use for these talking sticks. So we took that inspiration of the woven willow and created this structure, this pole that had these several strands. And it was kind of interesting because steam seems to come back up, but we had a review with high school students. And we were pretty proud of like some of these designs of what they did. And we said, to the high school students, what do you think? What's your input? And they're like, what do they do? What do you mean, what do they do? They're beautiful, these poles, like what are you talking about? Yeah, seems like they should do something. So like, that makes like perfect sense. They probably should. And so we went back to the drawing board. And the way we conceive, there's a few different poles, is as buffalo love to rub on things, and their hair is culturally significant and considered sacred. So a lot of times Native Americans will gather buffalo hair and they weave it in different things to make certain things. And so this is part of a prototype that we put out there, and the idea is a buffalo rubs up against it, and it's got a metal frame on the inside, and then these are kind of pucks that are stacked up that snap on there. When the buffalo pushes against it, those pieces open up a little bit and grab their hair. So they can rub on it, benefit to the buffalo, right? Scratch an itch, and then it collects the hair, which people can go and then experience buffalo in an expanded way. And so we used prototypes a lot. These are all like tests we did for different types of pucks that we could use. And what we actually came up with to make those pucks out of is corian. I don't know if you're familiar with corian, but it's used like in kitchens, right, for the countertop. It's a corian solid surfacing material. And when they cut out the sinks, they throw that stuff out, which is what this all is. And so we found a bunch of these, and this is what we used to cut out all the corian pieces for the whole thing. So we upcycled corian to use for the pole. So another thing as far as tools that we did is Daryl Growingfender's an artist in Poplar, Montana. And he worked with us on these workshops because initially we were going to paint the pole, but probably not such a good idea. Outside it's going to wear this and that. And so as part of that process, students developed these stencils And after this, we actually went to 4 different high schools on Fort Peck Indian Reservation. There's like 101 different stencils that incorporate into pole. But that came out as a result of doing this. And so we decided to, instead of painting it, is to CNC in the side of these pucks the different stencils. And so this is a thunderbird. And then these are some of the more poles, right? There's 4 strands that go up. And these are some of the ones from the different high school students. And so jumping these different tools that gave these different insights for design. Designing everything you can. Ducati motorcycle. A few years ago, we had the great opportunity to be in Italy, and we were in Bologna visiting the Ducati manufacturing facility there, which is amazing. And as part of it, there's a museum. And we were going through the museums, and we were looking at the motorcycles. And we got to near the end of it, and there were these racing motorcycles, and they weren't Ducati Red. Like Ducati Red is a thing, right? It's like their main brand, or really part of what they are. And it was orangish. And we're like, well, why is that? And we asked the guide there, and she was telling us, so this is Ducati Red, like their shirts. These are what the racing bikes actually look like. It's a little off, it's a little orangey. And she said, well, the majority of people don't see a racing bike out on the street. And they don't even go to the races. They see it on high definition TV. On high definition TV, Ducati Red is not Ducati Red. Because it's super saturated, it actually becomes purplish, right? And so it's not their color. So by painting the motorcycle this color, which is a little desaturated, a little orangish, on high definition TV, it's red. It's kind of red. So that idea, right, of really stretching design, of being rigorous about how you think about it. This is another project. We used to do work for United States Gypsum. They make these ceiling tiles, right? Not real exciting stuff. This was a lobby we designed, and as part of the lobby, instead of using the surface of the tile, we stacked them up. So it's kind of like walking through icebergs. It's kind of cool. We were asked to do a museum exhibit on ceiling tile. This stuff, right? Which was a challenge. And so what we did was to think more wider about the capacity of design and reach back into the process. And so this is actually slag. And so it's slag suspended in acrylic panels. And what we found out was that in 1920, USG invented this process of using slag to make their ceiling tile. So slag, which, you know, when you make steel, it like comes to the top, right? And we brush that off, and it's actually like contaminated and everything else, and I throw that away. USG invented this process where they take this slag, they grind it up, they melt it down, and then, and this was crazy. We while we were doing this, the USG representative came to the office and said, "Who wants a tour of the USG manufacturing facility?" Right? And we're like, "You really want to see ceiling tiles made?" Well, I was one of the ones selected, so I went. It was amazing. Like, we went there, and they had this room. It was like 12 by 12 by 12 foot. And on one side of the room, there was this pipe that came in, and they ground the slag up outside, they melted it down, and they shot, the room was sealed off, you couldn't go in it, right? They shot molten slag across the room, and on the other side of this room was this huge conically shaped steel wheel that spun around. And the slag sticks to the end of it, and then it slides to the surface slowly, and because it's a bigger diameter, it spins faster. And right before it gets to the end, it fluffs off into mineral wool. That's what mineral wool is. it looks like you're shearing sheets just floating all over the room. And they sweep that up, and they collect it, and then they mix it with gypsum and cast their cement tile. And it's that mineral fiber that actually gives it its fire protective qualities. It was like amazing, right? It was like mind blowing. And so we thought about the design not of whether it fits in the grid or whatever it does, but the design as a process that was related to slag. And if you look inside this lower tube, there's actually a TV in there, and that whole process that I just described to you, there's a film that shows that. This next project is a competition in Chicago. And so this has to do with different tools and thinking of things differently. So they had this competition, and at this time, so this is the 1990s, they were building townhouses all over Chicago. And the townhouses looked exactly the same. And the way Chicago is set up, it has 78 different neighborhoods. In each of those neighborhoods, like we used to live in the Ukrainian village, and you go to the playground, nobody spoke English. But the neighborhoods had such distinct personalities that they're very unique, right? Different places. And the problem with these townhouses, they were exactly the same. They didn't account for all these differences in these different places where they were being built. And so the Chicago Architectural Club had this competition. And they said, okay, we want you to design a townhouse that addresses this condition. And by the way, select any site that you want. I thought about it and I'm like, well, that's the problem, is that these townhouses, the developer is selecting their site, not their physical site. Their site is actually like an Excel spreadsheet where they're maximizing profit. So in order to maximize profit, if that's your site, an Excel spreadsheet, right, they're all going to look the same so that you're making the most money. So I was like, the competition itself is flawed. So what he did was, this is actually, and this is manipulated a little bit, but these are the words from the competition that they put up. And so I said, well, if you're not going to get a site, I'm not just going to pick my own. I'm going to select the site you gave us. In other words, the semiotic structure of the competition announcement is what I used for the site. So I took Noam Chomsky's, one of his theories of semiotics, which is diagramming sentences, right? Noun phrases, verb phrases, adjective phrases. And I diagrammed all the sentences of the competition. And they said your townhouse had to fit in the volume of what a townhouse would be. It's like 120 feet by 25 feet by 40 feet high, something like that. And I put the diagrams on this, which is its structure, right, as the site inside that volume. And then all they did was connect the noun phrases, the verb phrases, there's kind of these ribbons. And that's what the perspective, okay. So this is a while ago, right? This is in the 1990s, so computer technology has advanced a little bit. So, but these were perspectives from inside of that space. And it was kind of interesting because I worked for Valerian the Walk Train in Chicago at that time. And I didn't tell them that I was doing this competition, I did it on myself. And that night, after the jury had decided the winners of it, I get a call from my boss, Valerio. It's like, Mike, we just finished jurying this stuff. And I'm not supposed to tell you, so keep it to yourself, but you were one of the winners. I said, wow, that's fantastic. I really appreciate it. He goes, yeah, I didn't know you were entering because it was anonymous, right? Like you didn't know who's judging. I wasn't a big fan of yours. I didn't vote for it. And one of the reasons is if you were a winner, you had to build a physical model. And he said, I don't know how the hell you're going to build a physical model on that whatever. So this was a physical model. It was basically just plexiglass, kind of animated. This was solid plexi here that I cut the ribbons, right, as they went through. So anyway, but it was a way of critiquing design and thinking of design, right, as a broader process. The last couple of projects that I'm going to show are related to curriculum design. So all these different majors that you guys mentioned that you're taking, your professors are designers. They're taking your requirements that you need to know for whatever majors, and they're designing assignments, they're designing tests, they're designing the curriculum in order for you to learn that in the best possible way. They're critiquing their own design of the course, right, and coming back and changing it and so forth. And so that's a fruitful way to think of things if you think of curriculum as a design thing. This was design. I also teach professional practice, and this was actually a national competition that we had won, but the gist of it was that architects needed to know more and more, and they were designing more things. And by the time you were presented knowledge, you understood it in a test, when you got out to practice, the field was changing so much that maybe you were behind a little bit. And so what this proposed is that student projects would be integrated with the students that were doing projects the year before, and also basically to integrate more local architects with hands-on assignments. The other part of it was this idea of architect as a polymath, meaning you need to know more and more. And so as the curriculum advanced, these different stages, more things were taught in the curriculum. There's a little more to it, but it's more the idea that you design curriculum. And this is actually a diagram we did for first-year architecture students. Actually, a couple of you are taking this class. And so what we looked at was, this is a skill set that we needed to teach students. Reading, writing, diagramming, drawing, modeling, and making. These are the learning objectives of the class, right? Ordering systems you had to know about, and design thinking. These are all the assignments throughout the entire semester. And so this ordering system is taught in that assignment and that assignment. And so part of the strategy was to distribute the learning objectives and the skill set across the semester as much as possible. So this was a way of doing it. The other thing that's embedded in here is the darker colors are individual, and then the lighter color, like this is an individual assignment, and then these are group assignments. That was another strategy. So it was a diagram to help think about designing that curriculum. So this is the last thing, just to reiterate a couple of points that I have covered, is it's important to shift the mindset, right? Design as a noun to design as a verb, a process. And hopefully you can see by extending it and thinking about it that way, it opens up more possibilities. The second thing is craft, fabrication, engineering, technical project, or all of these, like entrepreneurs are probably one of the best examples of a designer. Like they take an idea, a business model, all these things, and they create space for that to be realized. Like amazing. Highly creative design solutions tend to create waves of innovation. So you're collaborating with other people. If you're working as a team with other disciplines, the more creative that solution is, the more innovation is that kind of ripple effect. And then, and this goes to that first point about attitude, right? Design is a way of acting responsibly to seek betterment in the world. And by expanding your definition of how you think about design and how you do design in creative ways, you have a better chance of doing it. Whoops. That's it. Thank you very much. Any questions on? Nothing.
Do you do all your work from MSU? Like directly? From here you do all these like projects? Is that all like from MSU facilities?
Yeah, you know, that's a great question. It's funny because like the projects in Nepal we had done here, right?
Yeah.
And a friend and I were presenting it up at Calgary, and there was a question that came from the audience, and they said, you know, that's really great that you're doing work, and stuff like that. But aren't there like some issues more local that you can address? And that was a great point. That was one of the reasons that we capitalized on the opportunity to work with the Fort Peck Indian reservation. There's pros and cons, right? But being a land grant mission school, our first priority really needs to be kind of in Montana. That's great. Anything else? Me?
I guess I'm interested in, as someone who's been in like many different forms of group project type environments, like with your curriculum design, like if you kind of conceptualize a group in a different way, or the affordances of that structure.
Yeah, that's interesting, right? Because the curriculum for any of your programs, you have accrediting boards, right, which are pretty set in what you need to be taught. This is a question that's come up in architecture. Can there be points in the curriculum to kind of take more risks outside of that, right, and address some of these other issues? And we haven't come up with a solution of how that's done, but we're thinking it's maybe in the beginning of the third year, end of second year, when enough of kind of basics are known, that maybe we can teach that. But that's a current question that I don't have an answer to. So when you figure that out, let us know. Yep.
Do you teach any classes at MSU?
Do I teach classes?
Yeah.
Yeah, I teach different levels of design. So this semester I'm teaching first year and third year design. I teach pro practice and different electives. Yep. Yeah. The great part about being in Montana, especially in architecture, is here. There's a lot of freedom that the university affords us and opportunities and you guys to do different things, which is really wonderful. Yes? Yep.
Where did you receive your degree?
So I went to school for a few years here, and because I was your age, it was a little too much fun. So I transferred to University of Texas in Austin. That's where I got my undergraduate degree. And then I worked for a while. And it was a little underwhelming. So I went back to graduate school and I got my graduate degree at Columbia University in New York, where they really emphasized concept, and it was very, very exciting. Good.
When did you know that you wanted to go into design and architecture?
My dad was an engineer, so I knew I didn't want to be an engineer. No, since early on. Anybody heard of the Brady family? The television show? Mike Brady, architect.
Kind of joke.
No, it's so you never do a project by yourself, ever. Like you always work with other people in architecture, right? And the feeling you have of being as part of a team, of drawing things and then walking into the physical manifestation of that idea, there's nothing better. It's amazing.
What was your favorite project you've worked on?
Favorite project?
Whole career.
This is going to sound kind of dumb, right? But it was this hinge that we developed for Abbott Laboratories. So Abbott Laboratories, I don't know if you know, they're a pharmaceutical company, right? And they have a campus in North Chicago. And as part of their campus, they have these huge gates, and each leaf of the gate is like 25 feet long, right? And these gates would sag, right, over time. And so we were helping out them, and so they wanted us to redesign the foundations for the posts, right? And we had an engineer working on it. He said, well, just make it, nothing against engineers, right? But let's just make the foundation 6 times bigger, right? And then it'll never move. And that didn't really account for the dynamics of the earth, right? And so what it designed is when you have the hinge and it comes in and it sets right on a pin that goes there, is it designed the bushing on the top and bottom to rotate a little bit So adjusting that pin like a 1/16 of an inch here makes like 8 inches difference on the end of that gate. So you could go and have basically a dynamic hinge, right? And I got it from the idea of my kids, like, you know, they pull those clown cars with the wheels on the opposite, and I've been like watching that, and I was like, yeah, that's it. And what was so the work, they didn't end up doing it, right? They built like the huge foundation of this. But like it would cost like a nickel, right? Like there's no cost to it. And what was so amazing, I thought about it, was like pure design. Like it's almost pure concept. And it takes into account the dynamics of the earth and what the thing is kind of immediate, right? I don't know if that's my favorite next project, but for me it's like the clearest of like what I kind of try to shoot for, right? Is this thing that's so lean, right? That it's almost pure concept. Anything else? Well, thank you guys very much. Appreciate it. Thank you.